4.4 is going to be a short in-speed section. It'll talk about the mean value theorem. So the mean value theorem says let f be continuous on the interval a and b and differentiable on the interval a and b. Then there exists a point c in the interval ab such that f prime of c is equal to f of b minus f of a over b minus a. All right, now what does that even mean? So first off, this thing here, f of b minus f of a all over b minus a, this is basically equal to the slope. Okay, so f of b is same thing as like y2 minus f of a, same thing as y1 divided by b minus a, which is x2 minus x1. So what this is saying is that, let's say, I'll give you an example here. Okay, let's say that we have a function that looks like this. So we have a closed interval. This is going to be a, and this is going to be b. And you have a function that's going to be given on this closed interval. Now, when we find the slope in between these 2 points, let's try that again. Okay, this is our function. So let's say we want to find the slope in between these 2 points. Slope is just y2 minus y1 over x2 minus x1. So the slope is going to be just this dotted segment that's going to connect them. And if we can keep it going and make it into a line, but that's going to be basically our slope. So what this is saying is that on this, in between this interval a and b, there's going to be some point c, like this is going to be point c, where the slope of the tangent line of c, so this is point c, and the slope of the tangent line at point c, which is also its first derivative, is going to equal to that slope. That's essentially what this is saying. All right, let me give you another example. Let's say we have another function in between a closed interval a and b. So this is going to be our a, this is going to be our b. We have this closed interval, and this function will look something like this. Okay, so actually, you know what? I'm going to extend this a little bit further down. Let me try that again. So let me start from here, and I'm going to go up this way, and here. So if I want to find the slope in between these 2 points, my slope is going to look like this. If I just connect these 2 points, this is the average rate of change, or the slope in between these 2 points. So what the mean value theorem says is that there's going to be at least one point, like let's say this is the point C, where the slope of the tangent line at that point, or its first derivative at C, is going to equal to the slope in between the points A and B. Now sometimes there are 2 points, like in this case, I can have another point, I'm trying to estimate it like maybe like here. And if I draw the, so it's a little bit over, but just imagine it's like here somewhere. And if I draw the slope of the tangent line at that point, you can see it's the same slope as the slope between A and B. That's essentially what the mean value theorem says. Okay, so the first example says find the average or mean slope of the function, and that's going to be given by f of x2 minus f of x1 over x2 minus x1. This is just another way of saying y2 minus y1 over x2 minus x1. So f of x1 is the corresponding output for x1, so that same thing as y1. F of x2 is a corresponding output for x2, same thing as y2. So this is going to be the average or the mean slope between these 2 points. So here's an example. Consider the function f of x equals to 2 minus 8x squared on the interval -5, 7. So when we see the term interval, these are the x values. This is not a point. This is not an x and y. This is the interval x1, x2. So our x1 value is going to be -5, and our x2 value is going to be +7. And what we have to do is we have to figure out what is f of x1 and what is f of x2. And the easiest way of doing that is just to plug in the x1 and x2 into this function. So if I replace the x with -5, we get -198. If I replace the x with 7, we get a -390. So then f of x1 is going to be -198, and f of x2 is going to be -390. And we get those just by plugging in the x1 and x2 values. Okay, so once we have that, we can now find our slope, which is going to be f of x2 minus f of x1, in other words, y2 minus y1 over x2 minus x1, which is going to be -16. Then it says by the mean value theorem, we know that there exists a point C in the open interval -5, 7, such that f prime of C is equal to this slope. So we got to find out what is f prime of C. So before we can do that, let's first find f prime of x. So f prime of x, 2 has a derivative of 0. And then for -8x squared, 2 times -8 is -16x. So that's f prime of x. We want f prime of C. So I'm just going to replace the x with the c. So we're going to get f prime of c is equal to -16c. And then the mean value theorem says is that for this point c, which we have to find, f prime of c is equal to the slope we found. So f prime of c, which is -16c, is going to equal to the slope which we found, which is -16. And then that just means c is equal to 1. Now, graphically, what is that going to look like? So graphically, if we go to desmos.com and we graph this function, f of x equals to 2 minus 8x squared. And then we're going to limit it to a certain interval, right? So to do that, I'm going to put a little squiggly bracket. And the interval we're limiting it to is between -5 and 7. So we're going to say -5 is less than or equal to x, which is less than or equal to 7. So now our function is going to be limited over this interval. And it's kind of hard to see because, you know, like these y values are pretty large, but you know, like it's going to be limited between -5 and 7. Okay, so what we're saying is that at x equals to 1, so again, this is going to be hard to see because of the nature of this function, but let me go to x equals 1. So x equals 1 is going to be here, and if I find the corresponding point at x equals to 1, it's going to be somewhere over here. If we draw a tangent line at this point, that tangent line is going to have the same slope as the slope between the points. And again, it's going to be hard to see because of how big it is, but it's going to be, if you draw a segment between these 2 points and find that slope, it's going to be the same slope as the one at x equals to 1. And that's essentially what this is saying. Okay, let's go to the next example. So the next example, we're given that f of x equals to 2x cubed minus 9x squared minus 24x plus 2 on the interval -4, 7. So we know that x1 is equal to -4 and x2 is equal to +7. And what we need is we need an f of x1 and we need an f of x2. Okay, so if I plug these in, then f of x1, so that's going to be f of -4, that's -174. Just plug this into Desmos or any calculator. F of 7 is 79. So my f of x1 is -174, and my f of x2 is going to be 79. And let me actually put a little box around this since it's getting close. From there, I just do y2 minus y1 over x2 minus x1, and I get that slope is equal to 23. Now, by the mean value theorem, we know that there exists a point C in the interval -4, 7, such that f prime of c is equal to 23, which is that slope. So first, let's find f prime of c. To do that, we got to find f prime of x. So f prime of x is going to be 3 times 2, 6x squared, 2 times -9, -18x, minus 24. And then f prime of c is 6c squared minus 18c minus 24. Now that f prime of c is going to equal to that mean slope, which is 23. Now for any quadratic, you got to get everything onto one side. So I subtract 23 and I get 6c to the second power minus 18c minus 47 equal to 0. This is going to be hard to factor even if it was factorable. So the best way to solve this is to use a quadratic formula, which is going to be negative b, that's negative 18, plus or minus radical b squared, that's negative 18 squared, minus 4 times 6 times negative 47, all divided by 2 times a, which is 2 times 6. And if you simplify that, it gives you 18 plus or minus radical 1452 over 12. You plug this into a calculator, so 18 plus radical 1452 over 12 and 18 minus radical 1452 over 12. It gives you 4.6754 and negative 1.6754. So those are the values of c at which the slope of the tangent line at c is going to equal to 23. And that's it. That's our lesson.